Hello, JEE enthusiasts. Welcome aboard to today's session where we are going to discuss torque and cross product and problems of pulleys and some really good questions where you need to apply torque. And you will definitely know about torque, or at least understand the idea of torque if you have played on a seesaw in a nice garden or a park. And you would know that you can balance yourself along with a fat guy or a heavy guy, even though you're not sitting at the equal distance from the point of suspension. And probably recollect your old school days where you would have tried balancing a sharpener, a plastic sharpener, and a heavy eraser or a rubber on a scale. Have you tried doing that? Balancing a sharpener and balancing a rubber during school? And you would have seen that the rubber has to be placed a little bit closer to the point where you're holding that scale than the plastic sharpener out there. That's the concept of, the torque, and I'm pretty sure you would have now recollected back your good old school memories. And obviously torque is used in many applications, like the one shown over here. Like if you want to bolt something, or you want to remove the screw from that joint, you have to apply the principles of torque. That lever out there is very large because then the force that you need to apply is very less, so that it becomes easy for you. And look at that dude who is being knocked out there. All right, again the principle over here is torque. So the larger the distance where you apply the force, the easier it is to apply that force to produce the same effect of rotation. And that's what we are going to study today in this part with me, Shreyas, your master teacher for physics at Vedantu, and I'm going live. So welcome aboard all the new members as well as the old members of our JEE Enthuse family. And JEE Enthuse is one of its unique kind of channel where we prepare you for JEE and all the competitive exams for 11th and 12th standard, be it Olympiads, KVPY, JEE, etc. And that too, this is an English channel. So a lot of people who demanded, we want to study in English because we are from English medium. Don't worry guys, this is a channel for you. So right now we have started with our Flash series. So if you see that our logo is everywhere, not on this slide but on other slides, is Flash. So Flash series is intended to complete the 11th and the 12th standard portion in the next 1 to 2 months. We have started just a month back and we intend to complete everything by February. And do not worry, if you are in 11th or in 10th standard, we are going to start again from March or April, where we'll complete the syllabus year long. So there will be long-term batches, etc. soon. And those of you who wanted to know about me, this is the slide which tells you everything about me. So I am a BTech in mechanical engineering and I have graduated from NIT Nagpur long time back, and my all India rank was 3,920 and I had almost full marks in physics. So that's a brief intro about me, and I have been coaching students for a long time. And this is my social media handle, Shreyas_Vedantu, where you can get in touch with me. So follow me over there on Instagram. So that's my Instagram handle. Welcome Fida, Manoj, Science Priya, Hoin, Dinesh, Ankit, and 17S Harni, and Dinesh, and so many other people, Uncharted, Saurav. Welcome Tanmay. Oh Tanmay, I guess you are the same Tanmay. I know personally, I've met you, I guess. Are you the same one? Hi Princey, Vidyashankar, VSG. Welcome. Oh yes, very good Tanmay. Kasakai bara hai? I am Mumbai. All right. Ersani and so many other people. All right. Well, Ankit, you have a surprise. Why don't you disclose it? Don't tell me it's your birthday. Aishwarya, welcome. Hi Aarti. Hi Bhavika, welcome. Hi Vemula. All right. So let's begin, guys. So keep in mind, yes, Krito messaged me personally. So guys, you guys have really formed a bond with me. I mean, look at that. Some of you have already messaged me on Instagram saying that, sir, my term exams are going on, so that's why I'll be watching the replay. So please, maaf kar do. And really good to see that bond coming up. Very good. That is what we intended to do in this channel. So we are going to form a bond. So that's how it is. And many of you have already messaged me why you are not attending for the next few days because of your term exams, and you're going to you're going to see the recorded sessions very soon. That's what you have promised. That's very good to know. Good. Thank you, Ankit. I mean, this is not surprise. This is something like you're thanking me. I am really glad that you are scoring really well in physics. Very good. Very good. Keep it up. I hope you will get 80 out of 80 also in physics very soon. Congratulations, Ankit. All right, Ryan, welcome. Well, let's begin. Yes, cyclone, maybe there is torque. Yes, Saurav, yes. And cyclone in Chennai. I hope you heard it in the news today. All right, let's begin our class. And in case you are a new member, or you are new to this YouTube platform or new to our channel, the way you can get regular updates and regular sessions from us is only if you hit the subscribe button down there, which is a red box out there on the right side, and the like button out there. So hit that like and hit that subscribe. Only then you can get regular updates from us. And if you want to tell more about us to all your friends, you want to tell how awesome this channel is, do not forget to hit that share button, and you can share it on your social media platforms like Facebook, Instagram, or WhatsApp, Telegram. That's up to you. So do, of course, share this channel link with all of your friends and your cousins. Yes. So let's begin. Hi, Janvi, welcome. All right. Now, I hope you remember all about forces. We have talked about forces before this. Force can change the direction of motion. It can also change the speed of the motion. That means it can change the momentum of particles. So it can change the momentum of particles. Now, do you know what is the equivalent of rotational force called, or the force which changes the rotational motion? What is that equivalent of force in rotation called? Well, yes, Neha, it's Pandu. Okay, so every time there is a lecture on torque, guys, you know what the doors in your classroom say? Do you know what goes on in their mind? Every time, any physics teacher who is teaching in the class, if you have seen, if you are fortunate enough to have attended a classroom kind of a teaching some time back, and if some teacher has explained to you about torque, I'm pretty sure the doors, if they could talk, they would definitely say this thing. Don't you agree with this? Ankit, one shot, I have already explained why I won't start one shot. Yes. Do you understand why the doors will say that? Yes. Aishwarya, Uncharted, VSG, Tanmay, Harni, and Windows too. Oh my God, Science Priya, my bad. Oh, so bad for the Windows. All right, all right. So this is what the doors and the windows have to say. So what is torque? Torque is the equivalent of force. And there we have that cute little Pandu coming out. And torque is nothing but the equivalent of force. So understand, force caused acceleration. Torque will cause angular acceleration. That's what it is. So it's the equivalent of force in rotation. Now just imagine this. If there is a fan above your head, most likely it will be off because it's winters and I'm wearing a jacket because it's very cold now. Anyways, so imagine if there is a fan up above your head, and if it is at rest, the moment you turn on the switch, you know what is going to happen? There will be a torque by the motor which will start rotating the blades of the fan. So that torque is causing rotational motion. And eventually you will see, after some time, the angular speed of the fan becomes constant. Now you will be like, oh, how is it constant? Because there is a torque by the motor. So if there is torque, then the angular speed should continuously change. But here is the catch. The catch is, in reality, we also have air resistance. So even the air resistance will give a torque like friction in the opposite direction. So the motor tries to rotate the fan in one direction, the air resistance opposes that same motion in the opposite direction. Both these torques cancel out each other, and you will see the net torque is zero, and that's why the state of motion, rotational motion, is constant. I mean, the fan blades continuously rotate with a constant speed. That's how it is. Now the moment you turn off the switch, the torque by the motor goes away. The only torque that remains is the torque by the air resistance. and that torque will again change the state of motion, and it will slowly decelerate the blades of the fan until it stops. And once it stops, the torque goes away and the fan stays as it is. I hope this kind of gives you a sense or an idea of what torque is. Is that clear? Everyone, is that clear? Very good. So torque is the equivalent of force in rotation which causes alpha, and I hope you remember what alpha is. Alpha is nothing but d omega by dt, just like A was dv by dt. So alpha is rate of change of angular velocity. That's what it is. Now let's see what is the value of torque. Now if you have ever tried to open the door, like this Pandu tried to open the door, obviously you will try to push the door at the end. You would be a fool to try and push the door somewhere here at the hinge. I mean, you can try that out. I mean, that's what doors are for. They are waiting for you to be pushed right now, and try it out how they will feel. I mean, guys, imagine if you push it near the hinge, it is very, very difficult. If you push it very far away, it's going to be very, very easy. So torque obviously depends on where you apply the force. So this Pandu is very smart enough, I guess. So it is pushing somewhere at the end, I hope. And that's when the door will be opened very easily, number one. Number two, when you apply the force, if the force is large, then the torque that you produce is also very large. That's very important. So torque depends on where you apply the force and how much you apply the force. And number three, it also depends on which direction you apply the force. Now imagine the door is like this. Yes, I will obviously open the door like that. That means the force will be towards you, right? It would be foolish of someone to actually pull the door this way. Imagine if you pull the door like this, I don't think it's going to open up. So understand, the force has to be applied, yes, as far away as possible, but it should be applied perpendicular to the line joining the force and the axis. This is the axis, this is the line joining the point and the axis, and I am applying the force perpendicular to it. That's when the torque produced is maximum. And if you apply the force like this, then there is no torque produced, because you will be just trying to remove that door apart, you will be tearing that door apart, but you will not be rotating that door. Yes. Okay. So imagine this green color thing is a body. This is a hinge or a pivot or a point about which it is being rotated, and you're trying to measure the torque about this point. Now imagine you apply a force here. All right, that's a force where you are applying, and that force will create some torque. So that torque will depend on how far from the axis you are. How far is that force being applied? That is R. And this force is not completely responsible for producing the torque. Let me tell you, this force can be split into two components. Remember, two components will be like this: one along R and second perpendicular to R. Think logically and tell me whether the force which is along R will be responsible for the rotation, or the force which is perpendicular to the R will be responsible for rotation. Let me know in the chat box. Yes, Achut, correct. Perpendicular, yes, Science Priya, yes, VSG, yes, very good. Not y-axis, but perpendicular, you got it. All right, Prajwal, probably you should put all these things in the comment box. Later on, I will respond to it. Okay, so if I call this force as F sine theta and this force as F cos theta, that is, if this angle is theta, then this is that force responsible for torque. And what about this force? This force is useless. It's useless. It's not going to create any kind of torque. It's just going to pull that body apart like that. It's not going to rotate it. And now the torque, by the way, the symbol for that is tau, that Greek symbol which looks like T, tau. In Hindi, that tau reminds me of a relative. I hope you get to know what I mean. Anyways, so yahan par this tau is proportional to R. It is also proportional to F sine theta. It only depends on F sine theta. F cos theta is useless. It does not create any torque. And this torque will then be RF sine theta. And then I can also specify the units of torque, which is if at R is equal to 1 meter, 1 Newton force acts perpendicular, that is theta is equal to 90 degrees, then the torque is 1 Newton meter. So just like work has a unit of joule, torque's unit is not joule, it is Newton meter, it is not called as joule. Understand? Although dimensionally they are the same, but they are not used interchangeably. Understand? So this is the magnitude of the torque and it is RF sine theta. So only the perpendicular force matters. In fact, many places I have also seen torque being written down as R into just F perpendicular. This is also a good way of writing the value of the torque. F perpendicular, which is F sine theta. So this is that perpendicular that I am talking about. This is your F perpendicular. I hope this is clear till this point, everyone. Rotational analog of energy is energy only. It is called rotational kinetic energy. Alright, everyone, got it? Alright, Asmi, so you're back on time today. Very good to know. Alright, very good. Let's get going. Yes, clearo. Excelente. Let's get going. Now, how do we show torque? Because I know torque has a direction, R has a direction, F has a direction, R is a vector, F is a vector, torque is also a vector, and you know this from one of my previous lectures that when work was defined and it was the product of force and displacement, we defined something called as a scalar product, and today we are going to define something called as the cross product or just the vector product. All right. So the cross product of two vectors A and B, which make an angle theta between them, the magnitude is given by AB sine theta. Remember the dot product A dot B? A dot B was AB cos theta. So A cross B is magnitude is AB sine theta. What is theta? Angle between A and B. Now you will be like, sir, what is the direction of A cross B? Very simple. Everybody use your right hand. I hope everybody has the right hands with them. Alright. So if you are holding your phone using your right hand, please switch it over to the left hand. Use your right hand and use these four fingers. These four fingers, and always put it in the direction. Alright. I'll just put that thing over here. Always, okay, let's say this is A vector, this is B vector. Put these four fingers in the direction of A. Then slowly move it towards B. Some idiot will say, sir, I can do like this also, A, and like that B. Please ignore, okay? So A is here, B is like this. Always go by the shortest route. If I ask you to hold your ear, you will hold it like this, no? I hope nobody will hold it like this. Will you do that? No, right? Yes, very good. Thank God, thank God. Alright. So you're going to go like this, guys. Very good. So when you do this, this thumb will give you the direction of A cross B. This thumb will give you the direction of A cross B. Very simple. That's called as the right hand rule. So you need to have your right hands in the exam. If you do not have right hands in the exam, then most likely you will not get the answer to this question. Okay? Chalo. Let's get going. And some geniuses I have seen in the examination. Kya baat hai Falguni? Very good. Rishti JEE B batch attendance. Very good. Rishti B students are also here. My original long-term pro subscription users are also here. Very good. Nice to see. So some geniuses in the exam solve two problems simultaneously, and this is what they do. A cross B is C. Okay, A cross B is C, and then they do C cross D is E. They are using left hand rule simultaneously. Guys, do not do that. Be careful. If you are a right-handed person, do not use left hand by mistake in the exam. Subconsciously, people have used left hand rule, so do not do that. All right. Okay. Anyways, getting ahead. A cross B is AB sine theta. If theta is 90, sin theta is maximum and that is 1. So the magnitude of this will be AB. That's the maximum value of AB. Alright, good evening Hajra Banu. Come on, join in. A cross B is AB. That's the maximum value. And what's the minimum value when theta is 0 or 180? Parallel or anti-parallel? Parallel means 0 degrees. Anti-parallel means 180 degrees. Both times sine 180 or 0 will be 0. Remember that. So very, very important rules. I hope you're writing all these things down apart from having that nice laugh that you have. Okay. Yes, dot is to cosine, so cross is to sine. Yes, correct, Achyut. Alright, next important property. Come on, write all these things down. Next important property. A cross B. If you do A cross B, you will get here. But if you do B cross A, it will go down. So A cross B and B cross A are not the same. Direction wise, they are opposite, but magnitude wise, they are same. Remember that. So as a whole, they are not commutative. Remember, dot product was commutative. A dot B was B dot A. Therefore, direction didn't even matter. It was a scalar product. This is a vector. So A cross B will be here. So B cross A will be down. So be careful about it. All right. Next. Okay, looks like a lot of my fans are here. Thank you, Neha. Anyways, so A cross B plus C. This is distributive. You can open up the brackets. You can write it as A cross B plus A cross C. This is distributive. This was also there in dot product. This is something which you should know. All right. I hope this is clear. Now, should I tell you one interesting rule? Let me tell you one interesting trick. Many of you will know it. If I tell you what is I cross J, what will you write? You'll have to visualize. Acha, I is there, J is there. I cross J will be like this. Oh, so it is K cap. Okay, I is along X, J is along Y, K is along Z. Similarly, if I tell you K cross I, K is this way, I is there, K cross I is like that. Oh, so it will be up like this. So K is there, I is there, so it will be J like that. Now, if you have to do more of these things, and if you're doing this in the exam, you will look like a retard doing this, won't you? Won't you look like a retard doing like this? So time consuming, yes, uncharted. So what is the easier way? Easier way, guys, I, J, K. So if you don't want to look like a retard, this is what you're going to do. Understand, anti-clockwise is negative and clockwise is positive. Now if you know this in cyclic order, that's it, your job is done. I cross J is K. Oh yes. K cross I is J. That's it, done. If somebody asks me K cross J, I'm going anti-clockwise. So first negative, K cross J will be I, the remaining part. So it's very simple using this simple cycle that you have over here. Is that clear? Very good, Tanma, Aishwarya, Sheetal, Jumnas. Yes, very good. Mast trick. Very good. Yo, let's get going to the next part. So now coming back to torque. So I just told you torque. When you write the magnitude, all right, when I write the magnitude of torque, R is important, F sin theta is important, F cos theta is useless property. So I just said the torque, by the way, is magnitude is RF sin theta. The direction is like this. Why like this? Think logically. If you apply force here, what will this big body do? It will rotate like this. No. Use common sense. Obviously, I am applying force here. How will this body rotate like that? Obviously, it will rotate like this. So the torque, use your curled fingers. Use your curled fingers like this. You will see the torque is coming towards you. The torque is coming towards you. Okay. So torque's magnitude was RF sin theta, and now we know what we can do about it. So torque, okay, one sec. So torque will be equal to something cross something. Now what cross what? Is it R cross F or F cross R? Very simple. Where is torque? Torque is coming towards you. Torque is coming towards you. Now if you do R cross F, it will come towards you. If you do F cross R, it will go away from you. So it has to be R cross F. Understand that. So that's the final formula for torque. It's R cross F. Yes. Is that clear, everyone? It is R cross F. I hope this is clear. R is here, F is there. So R cross F. Remember the smaller angle? That's it. If you do F cross R, F is there. F is there. Okay, F is there, that side. F cross R, it will go inside your thumb. Okay, that's what you should know. Very good. Now, a lot of people have that doubt. Sir, torque is coming towards me. Sir, torque is coming towards me. Sir, what is coming, sir? Because this body is rotating like this. What is coming towards me? I know if I apply force is applied on a body, I know the body comes towards me. But here, I am applying force here, torque is coming towards me. What nonsense is this? Guys, it is just a convention. Understand, if I tell you torque is 2I cap plus J cap. All you need to do is 2I cap is here and 1 J cap is here. So the torque is in this direction. This is the direction of the torque. Does that mean something is actually going there? No, nothing is going there. What you need to do? Everybody has their right thumb. Okay, use your right thumb. Put it in this direction. Put it in this direction. Automatically, if you are a normal human being, your fingers will curl in this way. Correct? If you are a normal human being, the fingers will curl in this way. That tells you, oh, the torque is like this. There is no confusion in that. I hope that's making sense. Alright, so that's avoiding that confusion. That's the whole purpose of defining it that way. Very good. Let's get going. And if you want to replay this part again, you can do that. Alright, Joshua is normal. Oh, Joshua, you are the same Joshua whom I know, I guess. Wow, a lot of my old offline students are also here. Very good, very good. And let me tell you guys, all the 12th standard students, dropper students, 11th standard students, important announcement for all of you. Because I know a lot of you have been asking me on Instagram and some of you also sent some emails and everything. Sir, if you want to study under you and all the teachers at JEE Enthuse, is there any option? Yes, there is an option. So we have the pro subscription offering in which you can study under, any teacher that you want to in the micro courses they offer, but you also get the regular courses, your normal long-term batches, just like you have in traditional coaching institutes, along with the test series, assignments, question banks, your module, which is a Tattva module, which contains all the problems from easy to hard level, and also you get personal teachers. This is something very unique, guys. Not many people know. You get personal teacher who will be constantly in touch with you. These are special people who have been trained to understand the psychology of a child, teacher, parent, etc., which will help you boost your performance. So that also is something that you get when you subscribe to our courses, and also you get amazing teachers with lots of experience and also the option of learning in Hindi as well as English. That's very, very essential. Just to name a few, all right, just to name a few micro courses that I am teaching right now is like the numerical micro course for just the JEE and the NEET students. It's on every Monday and Tuesday at 4 p.m. So if you're already a pro user, it's available for you at free of cost. Free of cost, it's available. Then HC Verma discussion session, again free of cost if you're a pro user. And again, derivation micro course, again free of cost if you're a pro user. So that's the benefit. And these are just the courses which I am taking over here. There are so many courses offered by so many other teachers, like for KVPY, for Olympiads, this, that, so many other things. So you can definitely benefit from all of this once you are a pro user. Remember that. And what are the prices? So for the dropper for 6 months, it's 51,000. But if you subtract 20%, you will be getting the course for just 40,800 for next 6 months. That's still your JEE Advanced examination approximately. And that's going to work out for about 227 rupees only for 1 day. And for the 11th standard students, the price for 6 months is 24,000, and you can take 20% off which will bring it down to 19,200. The cost works out to 107 rupees per day. Now, how do you get into these courses? There's a link in the description, guys. Hit that link. All your questions will be answered. You'll get all the pricings. For which course do you get personal teacher? For what subscription do you get this, etc. Every detail is mentioned over there. So please read it carefully before joining, and do not forget to apply the coupon code to get 20% off. The only way you can get 20%, that's the maximum offer that you can get. Nowhere else you can get this 20% off. That you have to use this coupon code SHHPRO, only then you'll get it. Is that clear? Yes, you can join mock test also. Sneha nange kannada swalpa gottu. Okay, that's the only thing I can do. So Joshua, HCV, a lot of it has been discussed, but all the sessions are recorded. So that's why you can always replay those sessions. That's the best part about this. Okay, I don't know guys how my Kannada was, but anyways. Okay, so some of you have been also asking, is there only a crash course, no subscription? Well, there is just a crash course for 12th and dropper students. Just crash course, nothing else. Which will have tests, doubt solving, test discussion, booklets, assignments, everything, but nothing else. So if you don't want those micro courses, etc., then there is just a crash course at a much lesser price. I'll tell you only for 12th and dropper students. I'll tell you that. All right. So here's the next question coming up on your screen. Keeping in mind, there are some 11th standard students. I have made this question. So otherwise, I would not keep this question because this is very straightforward. Come on guys, I'm expecting the answer on the chat box within next 1 minute. Starting the countdown now. Let's see how many of you guys give the answer within next 1 minute. The timer has started. F is given, R is given. Find the torque about the origin. Fida, I think you're facing some network issues. Please try and refresh, check your internet connection. Check whether others in your house are using the internet. See whether your data plan, etc. is over, not over. Okay, come on, Asmi, start it fast. Well, Saurav, I don't think it is 0. Check it again. Sheetal, think again. You have to give it. Get the answer in I cap, J cap, and K cap, not just the units. Oh, come on, the time is up. Okay, the time is up. Okay, so here is how you're going to do it. I'll teach you a short trick. Okay, some of you have got the answer. Let me see. I think Aishwarya, Science Priya, I think that is wrong, most likely. Let's see. So the trick, guys, is this. First write I, then minus J, and then K. This is what you should write down. Then remember, torque was R cross F. So whichever comes first, write those coefficients first. R's coefficients are 12, minus 10, and 3. The second vector's coefficient should come later on. 2, 4, and minus 10, I believe. Okay, just check this out. This is how it is. This is not 16, this is 10. Okay. Now, I hope this is clear till this point. Now, what you need to do is write down I cap, just put some brackets, then put minus J cap, and then put K cap over here. Now you just need to fill in those numbers. How do you need to fill in? Here is the logic. For I cap, ignore this column and ignore this row. Just look at these numbers and just follow this trend. This is the trend you need to follow. Go like this, just like you draw a fish or a rhomb. So minus 10 into 10, minus 10 into minus 10 will be 100. Then go like that, 3 into 4, 12, and then subtract the 2. Is that clear what you need to do? Okay, I'll tell you once more. For this column, for J cap, forget this column and forget this row. So just look at these numbers. So again go like that. 12 into minus 10, minus 120. 3 into 2, 6, and put minus sign. Similarly, for the last column, k cap, just forget the last column and the first row. So it will be 12 into 4, which is 48, minus 10 into 2, which is minus 20. That's it. Now do this, you'll get the answer, guys. I think it should be 88 I cap plus 126 j cap, and that is plus 68 k cap. That's the value of torque in IJK notation, but this is in Newton meter. Yes, got it. Vidyashankar, that's a shortcut. I mean, if you actually do the operations, that's what it comes out to be. So I have shortened the way. So if you remember I minus j and k, it becomes easier. That's all. Okay, that's just a trick. I mean, why it is like that? It comes by reverse engineering. Okay, great. So that's that question. All right. If they had asked you the magnitude of the torque, then the magnitude of the torque will be, understand. Okay, just let's get back. So if the question was the magnitude of the torque, then it will be each coefficient squares sum. So just take the sum of all the squares and put it under the root. That's what the magnitude would have been. Okay, keep that in mind. Chalo, let's get going to the next question. A rod of length L. Yes, it's basically determinants. Yes, Devendra, you can use it for all the vector products. Yes, for all vector cross product you can use it. Okay, very good. Chalo guys, come on, get it going. A rod of length L, mass M, pivoted at its end. What is the torque due to gravity? What is the torque due to the reaction? What is the net torque? Very simple. We are going to come to this question again also after some time. So what are the forces acting on this rod? There will be some hinge reaction over here. Let's say I call it some N, and there will be weight which will act from the center of mass of that rod, and that would be nothing but mg. These are the only two forces acting on it. Now you can choose one side as positive, one side as negative, as in you can say, let's say clockwise is positive torque, and you can then say, you know, anti-clockwise is negative torque. It's up to you. You can do the reverse also. It's up to you. So now let's write down the torque due to each force. So the torque due to normal about this point itself, here R is 0, so it will be 0 cross N. So it will be basically 0. I hope you get it. The normal force is passing through the pivot, so it will not produce any torque. Now the torque by the weight will be, direction wise, think about it. You don't have to do A cross D. Just think, what will this force do? This force will try to rotate the rod like this. Which direction is that? Positive. So make it positive. So first put plus sign because it has to be positive. If mg was up, I know it will try to rotate the rod this way. So that torque will be negative. Is that clear? And yes, what is the distance? L by 2. What is the force? mg. What is the angle? 90 degrees. If you have not understood why the angle is 90, look at it. This R is L by 2. I hope you get that, and the angle is clearly 90 degrees. So hence it is L by 2 mg. And if you add them, you will get the net torque. So this is 0 plus L by 2 mg. That's it. This is the net torque. I hope this is clear. Simple problem. Very good. Many of you have answered. Very good, very good, very good. So these are the answers. Excellent. Now let's slowly improve upon this. Let's slowly improve upon this. I'm erasing this. A rod of mass 4m has a point mass m attached at a distance of L by 4 from its center. It's supported by two strings as shown in the figure. Find the torque due to all the forces about its right end and left end. Let's try and do this. Okay, very simple question. And one more thing I would like to tell you from this problem is that, think about it guys, these two strings will give some tensions. Do you think these tensions will be equal? Obviously not. Why won't they be equal? Think about it. This point mass is not at the center. So I think the tension on this side will be slightly more it will, the string, the rod will try to bend more like this. So this tension will be more, I feel, and this tension I feel should be less. This is what my gut feeling says. I don't know if I'm wrong, let's see. Okay, now what is the next part? Yes, this distance is given to be L by 4. So if this distance is L by 4, obviously even this distance will be L by 4, and let's call this tension as T2, let's call this tension as T1, and do not forget certain things. This tension T2 will be like this tension T1 will be like that, this small mg will be like this, and from the center you will have 4 mg like this. I think the rod's mass is 4m, the point mass is m, and I think these are the forces. Now let's start from the left end. So I will call this L and I will call this R. So net torque from the left end. I think I know the answer for this. Yes, I already know the answer. You know what is the net torque? Should I tell you what is the net torque? 0. Why? Here it is not rotating. It's stationary, so the net torque should be 0. That's the best. So net torque is 0. But who all are contributing in this torque? Let's write that down. Let's think about it. There is torque by tension 1, then there is torque by mg, then there is torque by 4 mg, then there is torque by tension T2. All of them sum is 0. Is that clear? All of their sum is 0. That's their net contribution. I hope this is clear. Alright. Why have we taken mg? Because it is given in the question. A point mass is there. Look at that. Okay. Now, what is the torque due to tension T1? Well, that's 0. Think about it. It's 0, guys. Why? Because R is 0. You can clearly see that. Then, what is the torque due to mg? Well, mg is at a distance of L by 2 plus L by 4. What is the total distance? 3L by 4. I hope you can see that. In case you cannot see, just understand this much is L by 2. So, the total distance will be 3L by 4. So, it will be 3L by 4 into mg, and that is clockwise. Look at that. So, let's keep it as positive. Clockwise torque. Mg will try to rotate it about this point like this. So I'm making it positive. Next, 4 mg is at a distance of L by 2. So plus. Why plus? Because again it is clockwise. Look at that, 4 mg will try to rotate it this way. So L by 2 into 4 mg, and beware, tension T2, that's producing a torque this way. So it will be minus torque. And what's the distance? That distance is L, and what's the force? That's T2. And the best part, all the forces are perpendicular to the R vector. So sine 90 is 1 everywhere. So that's the best part, and this will be 0. I hope this is clear, everyone. I hope this is clear. Is it buffering? I'm not sure why it's buffering. Maybe for some it is buffering. I'm not sure. Just check your. Okay, it's buffering. I'm not sure, guys. My internet connection is pretty fast. It should not be a problem. Okay, then I think it's a problem. Maybe it's a problem because of that cyclone or something. Maybe some internet connectivity issues might be there. Maybe some lines would have got damaged. Maybe some places. Okay. So now, guys, you know what the best part is? Just by this equation, I can find the value of T2. Yes, we can find the value of T2. What is the value of T2? How do we find? Okay, just add both these numbers and cancel that L. So 3 by 4 mg. Okay, so 3 by 4 mg plus 2 mg. Take it on the other side. It will become T2. L has cancelled from everywhere else. So therefore, what is the value of T2? So 2 4s are 8. 8 plus 3, 11. So 11 by 4 mg. Just check this out. We have found the value of tension 2. Is that clear? Understand, VSG, the force of gravity will always act from the center of mass. Even pseudo force will act from center of mass. friction will act between the two surfaces. Normal will act perpendicular from the surface. Alright, so these are some things which you should know or understand, like by basic knowledge or understanding. Okay, I hope that's fine. Okay, now if T2 is known, let me tell you, you can also find T1 by the same approach. If you take the net torque about right point, think about it, net torque about the right point should also be 0. Why? Because the rod is not rotating, it is at rest. So net torque should be 0. So who all are contributing in this? Again, torque due to tension 1, torque due to mg, torque due to 4 mg, and torque due to tension 2. All their contribution totally is 0. Now you have to measure from the right side. Beware. Torque of tension 1 is there, guys. Look at that. Tension 1 is trying to rotate the rod clockwise. So I'll make it positive. So plus L T1. L is the distance, T1 is the force, L into T1 positive. Mg about that point R, look at it, it is trying to rotate the rod like that. What direction is it? Anti-clockwise. So minus L by 4 times of mg. L by 4 is that distance and minus because it is anti-clockwise. 4 mg, that's at a distance of L by 2. Even that is producing anti-clockwise. So minus L by 2, 4 mg. I hope you can see that this is L by 2, 4 mg is producing. It's trying to rotate the rod like this about that point. Notice the same force about this point produces this torque. The same force about this point produces this torque. So it depends where you are measuring the torque. And the last force produces 0 torque because about this point there will be no torque, of course. Now rearrange, cancel L, you will get T1 is equal to, okay, mg by 4 plus 2 mg. Now you can add them and you can see what is the value of tension, 1. So 2 4s are 8 plus 1 9, so 9 by 4 mg. So guys, you can find both the tensions using the torque, and we know that the net torque is 0. That's the concept I have used over here. Yes, coming to that, Krito, very good. So if you add both of them, T1 and T2, guess what do you get? T1 and T2, add both of them, just see that, 9 plus 11, 20, 20 by 4, 5 mg, correct. So you will get the answer. Originally, look at that, mg and 4 mg is 5 mg. But understand, just by T1 plus T2 is 5 mg, you will not get the values of T1 and T2. So understand, to get T1 and T2, apart from this equation, you need either the torque about the right point or the torque about the left point. Only then you will get it. Okay? Asmi, you are in 12th standard, that's why. Sorry, you are in 10th standard, that's why. Don't worry, it will look very easy after some time. You are seeing it for the first time, Asmi. Got it, Ankit? Very good, Krito. Very good, Joshua. What is a good JEE main score, Joshua? I will say 300. I'll be talking about it very soon. I'm going to conduct a lecture on how to solve JEE mains paper very soon. Don't worry, I'm going to conduct just a lecture on how to attempt JEE mains paper and what marks will fetch you, what kind of approximate rank and colleges. Don't worry, I'll get to that very soon. Very good. Let's get going. Next question. Got it. All right, Tejaswini, Princey. How 3L by 4? Sir, it is 3L by 2. S. Harni, I mean, depends which point you are talking about. If you are measuring it from this side, I think it was 3L by 4. Okay. L by 2 plus L by 4 is 3L by 4, S. Harni. So think about it. Okay, okay. So now, a ladder is leaning against a smooth wall. The floor has some coefficient of friction and is about to slip. What is the torque acting on it due to each force at the lower end, and what is the net torque? Well, let me tell you the answer for this part. What is the net torque? Net torque is 0. It's very obvious. Yeah, very obvious, no? This ladder is not sliding, it's given. And it's about to slip. It's not slipped yet. It's about to slip, so it's at rest. So net torque is 0 for sure. That's the first thing that should enter your head. In fact, Using this, you can find other things in this problem. Okay, so we are going to find the entire khandan in this problem. So you will see what that khandan is. So we're going to find all the family members in this problem. So let's get ready, guys. Yes, let's get going. First, start with the forces. Think about it. The rod's length is L, so the center of mass will be here. From that center of mass only mg will be acting. So mg will be here, like that. Okay, mg will be like that. Next, the rod will try to slip here. So friction will prevent the slipping by applying a force like that. So friction F will be here. I'll call it F1. There will be a normal force over here, N1. This friction obviously has to be mu N1. I hope you can see all of that. Okay, and Kevin, it was given that the mass of the rod is 4m. That's why it is 4 mg from the center. And always weight acts from the center of mass of the rod. Remember, pseudo force also acts from the center of mass of any object as such. Okay, next, there will be a normal from the wall like this. Okay, I'll call it N2. But there is no friction because it is given to be a smooth wall. That's the important word over there. Now, take this point. I will call it O. And we know net torque is obviously 0. So net torque about point O will be 0. That's very obvious. Who all are going to contribute? Torque due to normal 1, torque due to friction 1, torque due to weight, and torque due to normal 2. All their contribution will be 0. Now check, many of them will be 0, guys, their torques. Like the normal 1 will produce 0 torque because it is passing through the point. So that will be itself 0. In fact, the friction will also not produce any kind of torque. So that will be also 0. Weight will produce a torque. So in case you are now confused, what is the angle should I take and all that? So understand, this is your R vector. Okay, and this is L by 2. If you ask me what is the angle between them, actually the angle between them should be this angle. Understand, it is quite confusing if you look at it that way. So a better way of solving this, I'll tell you the better way of solving this. Okay, so observe this trick, guys. I have told this to many people before this also, but anyways, see, if you have R and if you have F, usually what do? Usually you split the force and then write torque. Torque is R into F perpendicular, correct? This is what you usually write. But let me tell you, there is no need of that. You can also do it this way. If there is R and if there is force, don't split the force. In fact, extend the force. Okay? And then drop a perpendicular like this on that force. This I will call it R perpendicular. The torque can also be written down as R perpendicular into force. Either ways work. So torque is R perpendicular into F or R into F perpendicular. It will come out to be the same thing. Is that clear? Is that clear, everyone? Okay, use this trick now. Now let's, no problem Tejaswini, join in. You can always replay the previous sessions later on. Now if you use that trick, it becomes very easy to solve this problem. This is my force mg. What is the perpendicular distance on it? The perpendicular distance is only this much. Look at that. This is the perpendicular distance on that force. And how much is this? If this is L by 2, this is theta, this is L by 2 cos theta. So it will be plus L by 2 cos theta into mg. Please understand, if you have missed that concept, this is R perpendicular. This much part. You can see that inside that triangle, and that is producing a torque clockwise. So I have made it positive. Okay, so it is positive. Is that clear, everyone? Very good. Next, normal 2. Normal 2 will produce a torque this way, again use the same concept, but it is producing anti-clockwise torque. So it will be negative. Now again check guys, what is the perpendicular distance on that line of force? This is that line of force. Just drop a perpendicular. You will see this is that R perpendicular. How much is this? This is L. Guys, this is L sine theta. Can you see that? This is nothing but L sine theta. Because this entire thing is L, so this is L sine theta. That's it. That will give you the answer. L sine theta into N2. Is that fine, everyone? Very good, very good, very good. I hope this is fine. Correct. Is that clear? Everyone, come on, everyone, respond. Waiting for all of you. See if everything is understood. Y minus, yes, Navmi, understood. Got it, Krito, Tejaswini. Little confusing, yes, Uncharted, because you are seeing my tricks for the first time. But if you start using the tricks, eventually you will learn how easy it is. Okay? Don't worry, Uncharted. At times it can be initially intimidating, but after some time it will look very easy. Okay, this is 0. So understand there are a couple of things in torque, guys. One is the direction, plus or minus. Second thing is the distance. And the third thing is how much is the force and what is the angle. That's all. If you do it step by step, you will get the answer. Now just rearrange, guys, and I believe you'll get whatever you want. So L by 2 cos theta mg is equal to L sine theta into N2. LL goes, and this will give me N2 is equal to cot theta by 2 into mg. See, I got the value of normal 2. So simple. Just writing these equations. I got the value of normal 2. Look at that. I got the value of normal 2. Is that okay? Now, let me tell you, you can find other things also. Okay, so once you get normal 2, you can find other things if you want. Very easy, I'll tell you how. Look at that in the x direction. There is no net force. Net force should be 0 because the rod is at rest, it is not moving. So in the x direction, can I say the friction from the bottom and the normal should cancel out each other? And if that's so, I know the value of friction should be N2. And what is N2? Oh, this one. So it is nothing but mg by 2 cot theta. Excellent. I got the value of friction also. So simple. Oh, now I know the value of friction. I know friction is also mu N1. Acha. So can I use it somehow? Yes. Why not? So let's use that. Friction, normal is nothing but going to be mg. Check it out. In x direction, N1 is going to be equal to mg. So why not substitute it? F1 is mu N1 is mg by 2 cot theta. So substitute the value of normal one, which will give me mg over here. mg goes and mu will come out to be cot theta by 2. In fact, you can also find the coefficient of friction from this. And if mu is given, you can also find the angle at which it is on the verge of slipping. Look at that. So many type of questions can be solved using the concept of torque and coupled with Newton's laws. Remember, be open-minded, understand the problem, whether net force is 0, net torque is 0, what is happening, is it in equilibrium, is it rotating, etc., etc. N1 is in y-axis. Yes. N1 is in y-axis. Oh, sorry. Yes, this is y-axis. My bad. This was y-axis. Correct. Understood? How is friction equal to normal? See, in x-axis, who has asked that? Somebody had asked. Saurabh. See this. In the x direction, there are only two forces, normal and friction. Nothing else is there. So they have to balance because the rod is not moving, right? It is on the verge of slipping. So that's why. Okay. So let's get going now. Which of the following is possible if F is the net force and tau is the net torque? Starting the countdown now. Which of the following? Multiple correct. These are multiple correct questions. Let's see how many of you get it. Type it out in the chat box. Okay, bye Asmi. More than one can be correct. Come on, guys. Okay, okay. A lot of people have started giving the answers. Hardly any time left. Hello, Amin. Come on, join in. You're a little bit late. No problem. Join in, but. Okay. Time is up. The correct answers are all of them are possible. Yes. A lot of you got it. I think none of you got it correct. So, here is the logic. Say, force is 0, torque is 0, obviously possible, like in the previous problems. That means the body is in equilibrium. Alright, something like at rest. This is the best example of this. All the forces balance, the torque is also cancelling out. That's the best example. Next, force is 0, but torque is not 0. I'll come to that. But let's come to this example first. D. D is, yes, most of the times this is true. Maybe that body is rotating and translating. So rotation is also there, plus translation is also there. That's why force is also not cancelling out, torque is also not cancelling out. So both the motions are there. This example, torque is 0, okay, so torque is 0, but force is not 0. Can you think of an example? I'll come to B, hold on. Torque is 0, okay, net torque is 0, but force is not 0. Example, imagine a body which is just translating. Imagine a body which is translating. So on it, understand there is no rotation. So the torque on it is 0, but force on it is there. That's a good example. Alright. So please understand this is not one force or one torque. Guys, you misread it. Understand it, Shakti and Uncharted. This is not one force or anything. This is net force. This is net force and net torque. Be careful. Okay, be careful. And lastly, this example, imagine a body like this, and imagine one force is here, another force, let's say 10 Newton, and this is also 10 Newton. These two forces cancel out each other, so net force is 0, but they are not acting at the same point, they will rotate, so net torque is not 0. That's the best example, and such type of, this example is also called as couple force. So couple forces are nothing but two forces equal in magnitude but opposite in direction. Very good, Navmi, thank you. Got it, everyone? So all the possibilities are there. Yes, all the possibilities. Okay, so that was the answer. Now let's take some examples where the net torque is not 0. So some pulley related problems where the pulleys have masses, and I'm going to give you some amazing tricks to solve the problem, guys. So get ready. So get ready. Good, thank you for all the love and likes, guys. Okay, so now, like I told you, when there is a mass and there is a force, it produces acceleration. So force is mass into acceleration. But when you have some body and there is a torque acting on it, it will produce angular acceleration. So in rotation, okay, so in rotation what happens? The torque acting on a body produces angular acceleration, but instead of mass you will have moment of inertia. Please keep that in mind. Also, one small thing, if you are measuring the torque about some point or axis, then the moment of inertia should also be about the same axis. So if you shift the axis, you have to calculate the moment of inertia about that axis. Keep that in mind. Rest all is simple. And this is always the net external torque. So remember that this is the equivalent of Newton's second law in rotation. Remember that. Okay, so write it down in your books, in your papers, wherever you are making notes, simultaneously write it down. Let's get going now to problems. Let's see the first problem coming up on your screen. This problem looks familiar to me. We have done this before. We just calculated the net torque. Let me remind you, there was a normal force and there was mg force acting here. So the question is, what is the angular acceleration? Very simple. Just use Newton's second law. It says net torque is I into alpha. That's what it says. So what was the torque because of? Not because of normal, only mg produced that torque, and because of the torque there will be some angular acceleration. So what is the torque? It is L by 2 into mg. What is the moment of inertia of a rod at the end? Remember, what did I tell you? Wherever you measure the torque from, exactly at the same axis, you should know the moment of inertia. So recollect previous session. The moment of inertia about the end of a rod will be moment of inertia about the center plus ml by 2 whole square. Why L by 2? Because this distance is L by 2. This is your parallel axis theorem. We have studied that yesterday. Alright, and that is ml square by 12 plus ml square by 4, which will give you ml square by 3. That is what you will get, moment of inertia at the end. Use that over here. That is very important. So use that over here, which will be ml square by 3 into alpha. Goes, one of the L goes. So I'll be left with G by 2 is equal to L by 3 alpha. Rearrange it further. Alpha will be 3G by 2L. That's the final answer. Is that okay? Yes, the best variable goes again. Yes. Alright, understood why I is not ml square by 12. Number one, that's a common mistake. Second mistake, people forget that you have to measure the torque and the moment of inertia about the same axis. That's the second mistake which people do. Okay? Done, done. Easy peasy lemon squeezy. Done, done. If it is done, done, then let's go to the next question. Okay, next question. Should I give this as homework? This is your homework question. But I will do a pulley problem now. So this is your homework question. Please keep that in mind. Let's see how many of you get the answer. Homework question this is. Answers should be put up in the comment box. So you will see the video over here. Alright. And you will see that red subscribe button. I hope you have already subscribed. And you will see that like button over here. I hope you already liked. And in the comment section below, you are going to put up your answers over there. Alright. So this is where you are going to put up your answers. This is your homework question. Alright. Let's get going to the next question now. Let's talk about some pulley problems. So pulleys with masses. We have seen pulleys where there were no mass. So now let's talk about pulleys with masses. So let's see what is the way to do that. Now, the common mistake which people do in pulleys is that, with masses especially, while drawing the FBD. See, again, the same problem I have taken in Newton's laws. Just the only difference is this pulley is like a disc which has a mass 2m. So when you draw the FBD, first 4m will go down, m will go up. So 4m has acceleration down, m has acceleration up. Cool. So 4m will experience weight, m will experience weight, and tensions and tensions. So weight 4mg, mg also this next weight, and the tensions on the top. Now the common mistake here, yes, I'll be talking about opening up method, 1 second. Okay, the common mistake here is people take the tensions as same. That is wrong. Remember, when the pulley has mass and the pulley also rotates with the thread. So when the pulley is rotating with the thread, the tensions on the sides of both sides of the string is not the same. That's the common mistake. So in fact, the tensions will be T1 and T2. The reason for that is, think about it, assume that the tensions were same. If the tensions were same, then both the tensions will give, one will give clockwise, one will give anti-clockwise. This pulley will not rotate. Now if this pulley does not rotate, guys, then what's the point? It will not have any acceleration only. Think about it. So it will not have any acceleration, and that's it. It will not move. So understand that it is very important that T1 and T2 will be separate tensions. Keep that in mind. So separate tensions, so T1 and T2 will be the extra variables over here. Is that clear? I hope this is clear. So the net torque, understand, is produced only because of T1 and T2. Now I'll show you the long method first. So the long method goes something like this. See, if this is acceleration A, this one will go up with acceleration A, and this pulley over here will have some angular acceleration. Oh wait, 4m is this side, right? So it will accelerate like this with some alpha. That's about it. And there will be some reaction from the top. All right. So there will be some normal force from the top on the pulley. Understand? So the pulley will experience a normal from the support. So that support will exert a normal on the disc like structure. Now I will talk about Menti uncharted. Just give me some time, Princey. Hold on. Now the equations will look something like this. Observe. For 4m, it will be 4 mg minus T2 is equal to 4m into A. Standard Newton's law equation. For which is that mass? M mass. For M mass, it will be T1 minus mg because it's moving up. T1 minus mg is equal to m into A. That's the equation for M mass. For the pulley, don't write FMA. You will write tau is equal to I alpha. Be careful. So for the pulley, how is it rotating? Anti-clockwise. Who is giving torque? Normal? No. T2? Yes. T1? Yes. T1 is giving opposite torque. T2 is giving assisting torque. It's helping that alpha. So T2's torque, I'll take it as positive. Just like over here, 4 mg was helping A, T2 was opposing. Same way, this T2 is helping alpha, T1 is opposing alpha. So let's say the radius is R. So the torque of T2 will be R into T2. Torque of T1 will be R into T1. Minus sign is there because it is opposing, is equal to I. What is I? It's a disk, right? So 2m into R square by 2 into alpha. These are your equations. Now here is the logic. See, you have 3 equations, but I'll tell you how many variables are there. 4 variables. Count. 1, 2, 3 and 4. A, T2, T1 and alpha. 4 variables. So you need one more equation, and I'll tell you where that equation is. Look at this disk, guys. On this disk, each point has some acceleration. And whatever is the acceleration on the tangent, that's exactly the acceleration of the thread and the block. The thread comes down with A, that's also the tangential acceleration. So A will be equal to alpha into R, that's circular motion. Now solve all these equations, only then you will get it. Only then you will get it. But this is a lengthy method. Should I tell you now the shortcut method? Should I now tell you the shortcut method? So this is how it is. Okay. But you should know this method, no doubt. The shortcut method, opening up method. We have seen this in Newton's laws. In case you have missed it, please attend it again, because I have already done quite a few problems in Newton's laws. But here is a small change. When you open up, okay, so understand 4m and m will have weights, and you open up that string against that pulley. So open it up like this, it will look like this. Now once you open up, understand even their weights will come like this. It will be 4 mg here and mg here. Just one change, do not forget the pulley. That's the only change. Because the pulley has mass, it is rotating, so that's going to cause that change. Now recollect the formula. The formula was acceleration is pulling force minus opposing force divided by the mass, the total mass. But the change here is when the pulleys are also there, then also add the pulleys mass, but not directly. So the pulleys mass was 2m, right? Don't add direct mass. Add the equivalent mass. That's the trick. Now what is this equivalent rotating mass? Here is the answer. This equivalent rotating mass is the mass multiplied by that factor which comes in moment of inertia formula. Which factor comes in the moment of inertia formula? Half, 2 by 5, 2 by 3, 1 by 12, 1 by 3, etc. or 1. So that factor is what you will use. That's all you have to use. So think for the disk, what is that factor? For a disk, what is the formula? mr square by 2. So what is that factor? Half. That's the factor which will come over here. So understand, if I had to use this formula to find their acceleration, the value of the acceleration will be, understand, pulling force, which is 4 mg, opposing force mg, upon total mass 4m plus that m plus equivalent rotational mass. What is the mass of the disk? 2m, but multiplied by half. Why this half? Because it's a disk. That's all. That's the shortcut. Now do this and see what answer do you get. I think this will become 3 and this will become 5 and this will become 6. So 3 by 6 G mm goes, and that will give you G by 2. That's the direct answer. Is that understood? How this has to be done? Very simple. Use this, you'll get the answer. Very easy method. I'll give you one more question, and I hope you guys are ready for one more question so that you can get a hang of it. I will show it to you directly. All right. So let's get going to the last question of today. Again, there are two pulleys, two masses. Both the pulleys have same mass and they are identical. They are disc-like. Now imagine if one were to solve it normally, what a dance he has to do. Tension 1, tension 2, tension 3. 3 tensions will come here. It's going to be crazy. Too many equations. You will not have so much time in the examination. So what is the best way? Use my method. Acceleration will be, okay, wait, I'll show you the opened up diagram. That will be better. So this is the opened up diagram now. Now let's do this. This is 3 mg. This is 2m. This is 2m. This will be mg. But let's find the equivalent mass. This is not the equivalent mass. The actual equivalent mass will be 2m into half, which is just m. So this is the mass you should consider. So even this 2m will become m. Why? Because they are discs. I think it was given previously. So they are disc-like objects. So the factor that will come over here will be half. Now just use our method. Bigger force 3 mg, opposing force mg, total mass 3m plus m plus equivalent rotational masses m plus m, not 2m plus 2m. Do this, you will get this as 2 mg divided by 3 plus 1, 4, 4, 5, 6. So this will become 6m. So that will make it G by 3. How easy it is? Look at that. Amazing. Did you love this method? And if you love this method, you should also hit likes. You should also give me some likes out there. If you've already done it, well and good. So easy method, guys. I hope you see that. Okay. Now, I actually wanted to do this yo-yo problem also. I'm thinking I will post up a video solution on Telegram. Okay, so I'll post up a video solution of this yo-yo problem on Telegram. All right, something like that. So try to solve this yo-yo problem. Yeah, so I'll be posting up a video solution of this yo-yo problem. I want you to do this yo-yo problem and post up the solution again in the comment box. So 2 homework problems for today, but don't worry, I'll be also posting the video solution of this hopefully on Telegram. So where is the Telegram group? It's in the description box below. So go ahead, join the Telegram group right away. I'll be posting the solutions only there. Keep that in mind. All right, yo-yo problem. What is yo-yo? Yo-yo is this. Yo-yo is this. This is yo-yo, not that emoticon. This is that yo-yo. So you leave this disc, it falls like that. So what is the acceleration of the yo-yo as it goes down? That's the yo-yo problem. And I was telling you about the crash course, right? For all the 12th and the dropper students, I have also pasted the link. It's in the description box. You can check it out. And the actual price was 10,000, but 20% off again. So you'll get it for 8,000 rupees only. So 8,000 rupees mein you'll get test series, you'll get assignments, you'll get test series discussion, regular sessions. How many sessions? There are too many sessions. You are going to get around, I think, 120 sessions. Yes, 120 sessions in this crash course, along with 10 full and 10 part test series, and also lot of revision sessions, etc. So the coupon code is SHCC. That's the coupon code for the crash course. I hope that's clear. So all the new members, do not forget to subscribe and do not forget to share this video and also like this video. I hope that's fine. All right, guys, this was Shreyas here. I hope you have enjoyed this session. Take care. And mentee session will not happen tomorrow. It will happen day after tomorrow. So what is tomorrow? Only dipoles and dielectrics. Lots of problems. All the 12th standard students listen in. Dipole related problems, potential electric field related problems, and the theory for that, and also what is dielectric constant, etc. All these things will happen tomorrow 7 p.m. sharp. So all the 12th and the dropper students, see you tomorrow at 7 p.m. and the mentee will happen on Friday morning on dipole, dielectrics, gravitation, Kepler's law, satellites, field, potential, Gauss law, all chapters combined. You will see a mentee session happening on Friday. So that's what is planned. All right, I hope I have answered all your questions. Take care, see you. Do not forget to comment in the comment box below all the homework questions as well. See you guys. Bye bye. Take care.